seconds. We do have polls today. They will be within Zoom, so a little box will pop up when I generate it. Please answer as soon as you can, and then we'll share the results. There will be 3 PDH questions at the end for those interested in getting PDHs. If you have any questions for Willie or any concerns with Zoom, put them in the Q&A. That's the way to get a hold of Jody and I. And then we won't be putting anything in the chat today. There's no handouts, but anything will be in the follow-up email with your attendance certificate. And with that, I will turn it over to Willie.
Good morning, everyone. I'm Willie Grimke. I'm here to talk about culverts today. And what we're going to go over a little bit is the types of deterioration and preservation techniques for culverts. Little background about myself. I'm a professional engineer in the states of New York and Vermont. I've had over 30 years of experience with highway and infrastructure maintenance, construction, and stewardship. I currently work for Greenman Peterson. I teach for Cornell Local Roads, and I spent 13 years as the county highway superintendent in Washington County in the late 90s and 2000s. So if you we're on Zoom, which means you get to listen to me talk to myself for the next hour. Check your audio. There's no chat. If you have a question, type it in the Q&A. So this will give you a professional development hour. One in New York State, only for the person registered for this course, and you'll get a certificate of attendance sent to you. I'm guessing there aren't too many folks from other states, but if you are, let Amanda or Jody know. Or check with your LTAP center in your state. So our learning outcomes today, we're going to discuss common deficiencies that are identified in culverts, describe preventive maintenance of culverts, and review culvert repairs. So we're going to start out with some poll questions so I can get to know who you are. I looked at the list pretty quick and I recognize a couple of names. So what's your primary job function? Administration, commissioner, engineer, field crew, board member, or none of the above? Okay, survey says we got 55% engineers, we got 27% highway superintendents or DPW commissioners, and then we've got a scattering of field crew, board members, administration. Okay, next question. Who do you work for? Village, town, county, city, state, private sector? Okay. Got 20% working for the town, 20 for the county, a little less than 20 for the city or village, and we've got a quarter working for private sector, and we've got somebody from tribal government. Great. And we've got some people that are working for the weekend, which is good too. Okay. Level of experience. How long have you been in your current position? Less than a month, less than a year, 1 to 2 years, 3 to 5, 5 to 10, 11 to 20, or are you one of the 20 plus dinosaurs like myself? Okay, so we got a pretty good, we got some new folks. We got some folks in the mid-career range and some folks that have been doing this for a while. Great. So next question, how many culverts in the 5 to 20 foot span do you have in your system? None? 1 to 10, 10 to 25, 25 to 100, or over 100, or I have no clue. Okay, answers. We got 5% that don't have any. We got 5% with a handful. 11% with some, and then we've got about half our group has between well over 25. So that's great. So you all have a vested interest in the discussion today. Okay, so now we'll move on with our discussion. So for what we're talking about today, we're going to go over some terminology just so everybody's on the same page and understands what we're talking about. The invert, that's the bottom part of the culvert where the water flows in low flow situations. The crown is the top of the culvert. The spring line is the widest part of the culvert. If it's round, it's at the middle. The haunch is the area between the spring line and the invert, and we'll talk about that a little bit because during installation of culverts, haunch support's very important. And the bedding is the material underneath the culvert that's supporting it. It may be native material, or it may be an imported material, depending on what your local soil conditions are. So that was a cross section. Here's a profile view of things we'll be talking about. In front of the culvert, at the invert, you may have an apron. Some do, some don't. In front of the apron or at the entrance to the culvert, you may have a toe wall or cutoff wall to prevent scour from undermining the culvert. We may have a wing wall or end section. We may have a parapet to retain fill. We have the barrel of our culvert, be that metal, plastic, concrete, and in segmented culverts, we may have a joint. So culverts come in a variety of shapes. They may be round. They may be horizontal elliptical, which are commonly referred to as squash pipes. We may have square box culverts. We may have bottomless concrete boxes. We might have bottomless arches. We might have metal box culverts or plate arches. So variety of shapes depending on the hydraulic conditions and the conditions that you need for the particular application. Now, culvert materials, there are common materials we use. One of the more common one is concrete. Concrete is rigid. It for it to adequately perform, it's dependent on the bedding, particularly for round pipes. For bottomless boxes, it's dependent on the footings or support. Concrete typically has a smooth interior. If it's pipe, the joints are about 8 feet apart, and sometimes it can be skewed. And here's some examples and photos of concrete pipe. There are a pair of round pipes up above. As I said, horizontal elliptical. You can also get vertical elliptical. Concrete does come in arch pipes, and the lower photo is a precast concrete three-sided box or bottomless box. You can see it's going to have a natural stream bottom. And you can also get precast and cast in place box culverts in concrete. Other material we commonly use, although it seems like it's becoming somewhat less common, is corrugated metal. Now, corrugated metal is flexible, and how corrugated metal performs is largely dependent on the interaction with the surrounding soil. To some degree, with both corrugated metal and corrugated polyethylene, because those are flexible pipes, most of the structural load is being carried by the surrounding compacted soils, and to some degree, the metal pipe or the plastic pipe is kind of a form for that soil when the culvert's being installed. The corrugated pipe has a rough surface inside. It's corrugated. So as a result, it can have some flow characteristics and may have, from time to time, depending on the performance of the culvert, some penalties for capacity. And with metal pipes, the joints are typically 20 feet apart. And here are some photos of round metal pipe. Here's a trio of them. And if the dimension from the spring line of the two farthest ones apart is 20 feet or greater, this would be categorized as a bridge, not just culverts, but this is a culvert constructed structure. Now, metal pipes can be corrugated steel or corrugated aluminum. Round ones up to 15 feet in diameter. Plate arches, you can get up to 50-foot spans, and bottomless arches up to 55 feet. Now, with plate pipes and arches, which are assembled in parts, as you can see in this photo, these are bolted together. It's not necessarily 20-foot joints. It's individual plates that are bolted together. And finally, we get to polyethylene, which seems to have become more common for smaller diameter pipes. It's flexible. It often comes as a smooth interior, but also corrugated, like metal, depending on interaction with the surrounding soil. 20 joints 20 feet apart. Advantages of plastic are it doesn't rust. It's lighter and typically a little easier to install. And this time of year, what we found when I was working for the county in locations where we had issues with culverts freezing, when we went to the smooth line polyethylene, it tended to thaw out quicker and the big chunk of ice would slide out rather than having to spend time with steamers and calcium chloride and things like that to try and thaw the pipe out. if there's a takeaway today, this would probably be it. Installation is critical to your proper long-term performance of the pipe. If you don't properly bed and compact your culverts when you install them, the probability of having a performance issue later in the life of the culvert is greatly increased. So you want to make sure they're installed correctly. So we're going to talk a little bit about common defects. We're going to go over debris and siltation. We'll talk about leaking joints, settlement and sinkholes, scour, damaged coatings for metal pipes, invert damage, localized damage, cracks and spalls, which are common in any kind of concrete, and pipe deformation. So here we have a photo of a pair of plate arches, relatively on a town road here in Washington County. And as you can see, the way the stream is flowing is putting a silt bar in front of one of the pipes. So, and this illustrates some of the challenges with debris and siltation. We get a big rain event with all the silt and vegetation in front of the one pipe. It's not going to take the flow that it's designed to take. And the silt bar is kind of altering the flow and pushing the channel bottom over to the far left in the photo, which can potentially undermine the inlet of that pipe. So we've got scour, we've got flow alteration, we've got reduced capacity. This is the inlet side, so we can't really see what's going on at the outlet, but with concentrated flow and increased velocities, you can get scour at the outlet, and scour at either the inlet or the outlet can cause undermining of the culvert. And then if we get a big rain event and the culvert can't handle the capacity, it can lead to overtopping. And we really don't want to see that happen, because what will happen if it overtops, it can erode out the whole embankment over the whole road embankment over top of the culvert. We can get soil in our culverts, and that too can reduce our capacity, because that soil is occupying space where the water cannot flow. Now, depending on where you are and some of the current guidelines with new culvert installations, we may be installing culverts that are embedded, which have a natural bottom. But typically, if that's the case, we're doing that with a culvert that's designed for it, and it's oversized. So we have adequate waterway capacity, even with the soil in the bottom. But in many cases with our older culverts, that's not the case. And the soil in the culvert may result from stream hydraulics, meaning the stream is depositing soil in there. You may have a slow, flatter area in our stream after the stream is carrying a fair amount of soils and it drops in our culvert. That could be a problem and clog it over time. Or we may have joints failing and material leaking into the culvert. So here's a case of some of the bad things that can happen with debris in culverts. This was taken on State Route 149 in the town of Fort Ann, and there was a dam failure there back in 2005. And it washed a lot of debris into this twin concrete box under State Route 149. And as you can see, there's somebody's fuel tank, a lot of woody debris. And zooming back out, here's a wider view. Because of all this debris that got clogged in here, the culvert couldn't handle all the water that was flowing through. It overtopped. There was a roadway up here above the culvert, and that is now gone. The embankment was washed away. And what that resulted in was having to come through and restore the road. There was some undermining as a result of this event, and the state came in on an emergency contract, grouted it up, and restabilized it. But keeping debris out of your culverts is critical for long-term performance of the culvert and the embankment. Leaking joints. That can be caused by a number of issues. In the upper photo, you can see you have joints are misaligned or separated. In the lower photo, we have a bell and spigot concrete that's been damaged during shipping and handling. So that can cause leaking. The other thing that can happen if you have poor bedding or subgrade, over time they can move or open up. I've seen issues where concrete culverts were placed on clay soils with a large embankment over top. And as that embankment causes the clay to settle and the culvert settle, the joints open up. So you want to be careful in high embankments what you're installing, because that could potentially cause an issue with joints opening up. So in and of itself, the joints may or may not, open joints may or may not be that big a problem, but it allows other problems to happen. You can get water infiltration or exfiltration. Infiltration, as you see in the photo on this cold day, water coming in through the joints and freezing. And that ice could potentially cause blockages once things start to melt. That water could be carrying soil with it, which is part of your embankment above. If that water continues to carry soil through the open joint, it can cause sinkholes in the pavement surface above, or it can carry bedding, so the pipe is destabilized, and then you start to have problems with your pipe structurally if the bedding's destabilized. So here's a photo with a joint failure and lots of loss of soil. And so you've got the combination of, you've got soils coming through, so you may have a sinkhole or something going on above. You may have, and if you get a storm event, you've got a clogged pipe or one that's not going to pass water. So this has a multitude of problems for you. And in addition, this pipe also has a perforated invert. So here are some of the problems leaking joints can cause. This photo was taken about 3 months after this road was paved. It was a mill and fill, and the vibration from the vibratory roller over top of where the storm line was separated a joint, and this little hole appeared. Well, it turns out that little hole when we stuck a ruler down it, was probably 4 foot deep and 4 foot diameter, and all the material around the joint in the 3 months since the road was paved drained out. We got washed away, and then we had a bigger issue to fix. We can get scour and undermining, depending on the velocities coming out of the culvert. It can scour a hole either at the inlet or an outlet. In this particular case, there was a lot of water coming out of these boxes, and it scoured out the hillside adjacent to it. And those scour holes at the inlet and outlet can progress under the culvert, removing the bedding and destabilizing the culvert. And as you can see in this one, to the left of the culvert, destabilizing the embankment also. I went back to harping about installation. One of the things that can happen with poor installation practices, and I suspect in this particular photo, when this corrugated metal culvert was being installed, somebody may have backed over it with the track hoe. It can cause the joints to separate. It can have capacity impacts. This culvert isn't going to take nearly the amount of water that a fully round one would. And then depending on the degree of dents, damage, deformation, it may limit your options if you need to reline it at a future date. You know, slip lining something like this may not be an option unless you're going with a very, very small pipe. And here's another, this is a plate arch, and this also has a big sag in the middle of it, that midway through the pipe. And this was also due to issues during installation. If you have concrete pipes, one of the things you can be faced with, like any concrete structure, is cracks and spalls. And those can happen over time, but from normal concrete behavior, either reinforcing starting to corrode, or for spalling, or concrete cracking. However, where your cracks occur can be an indication of what's going on and how it's behaving. For longitudinal cracks in a concrete pipe, if you have longitudinal cracks at the 12, 3, 6, and 9 position along the length of the pipe, it's probably due to poor side support. So that pipe has a tendency to squash, and that's where the cracks will occur. And if you have cracks at basically the longitudinal cracks at the 5 and 7 o'clock position, just outside the invert, that's shear cracking due to inadequate support at the haunch. So those are things to look for so you can understand what's going on if you see cracking. And then if you have good side support and good support in the bottom, your concrete pipe shouldn't crack. Now, transverse or radial cracks. The whole different mechanism causing those, and that's due to support, inadequate support at either the ends of the pipe sections or the beginning. So if it's at the crack is at the invert, it means the middle of the pipe isn't supported. And if it's at the crown, it means the end isn't supported. And this illustration will show both broken back and broken belly. In the top view, everything's well supported. It's in good shape. It's not cracking. However, in the illustration below, if the bells are supported, but the invert of the pipe at midsection is not, you'll get cracks in the bottom. And then if it's supported at midspan but not at the bells, you'll get cracks in the top, because that's the tension area of the concrete pipe. And as we often know, concrete tends not to perform that well in tension. It's really good in compression. Now with metal pipes, one of the things we're faced with these is damaged coatings. Typically our metal pipes, it's galvanized, it's corrugated galvanized steel, and that galvanization is a sacrificial coating that is meant to last many years and protect the steel underneath. Once that galvanization is gone, then that steel can start to corrode, and that's when we start to have problems with inverts failing. And, you know, looking at this photo, you can probably guess where the ordinary high water mark is for this corrugated pipe. So how corrosion starts in steel, usually you'll get pitting right in the areas that are wet regularly, or right in the splash zones right near the water line, where you have a good combination of moisture and oxygen. So it can, the corrosion can get started and rust can occur. It can be more severe or more quick in areas where we have acidic or saline water. I was in Texas a few weeks ago and talking to the folks there near the coast, and they use almost all concrete pipe because of the salinity of the water. Just rusts out metal pipe very quickly. Also, depending on your soils, if they have low electrical resistivity, again, depends on the types of soils, that can cause corrosion to accelerate and occur a lot more quickly, and you won't get nearly the life out of your metal pipe that you're looking for. Invert deterioration, it can be caused by abrasive bed load. Basically, the waterway is carrying a lot of sand and gravel and material that scours out the bottom of the culvert as it's going through. It's basically like a waterborne sandblast, and in time that can destabilize the culvert. So as you can see in these photos, corrosion can basically eat out your invert, and it can be caused either by abrasion or corrosion, or a combination of both. Usually they work in concert with one another. And ultimately, what you see here in the photos, the inverts are gone, and that will destabilize the culverts and can cause it to collapse. We can get settlements in sinkholes, and very often, because we don't look at our culverts as much as we probably should, that's our first indication that we have a problem. Is we get a call on a Saturday afternoon, or hey, there's a big sinkhole on the road. So we go out and take a look at it, and there's been a problem with the culvert washing soils away, and we just haven't had the opportunity to catch it. So now we're in a situation where we got to fix it right away. And a settlement or sinkhole can be caused by either open joints or a totally failed invert, as we see here. And then one thing we definitely are trying to avoid is total and complete collapse. So when we get to this point, we're replacing it, and there's not much we can do. So how do we keep our culverts in good shape? Well, we'll start out with preventive maintenance. We want to remove debris and sediment. We want to get the vegetation out of there, and we want to do some armoring for scour protection. Removal of silt and debris. This is a stock gate that ended up in this culvert, and it's accumulating woody debris here, and then we have silt in the bottom. So we want to get this cleaned out. Now, the method for cleaning out our debris will depend on what we're moving. Is it silt? Is it a beaver dam? How big is our culvert? You know, what kind of access do we have? And what are our environmental restrictions? You know, so things we want to consider: environmental. Do we need to contain our silt and debris? Do we need to suck it out? Health and safety. Do we have contaminants in the water? Is it a confined space? Do we have fast moving water? We don't want to put our people in any kind of harm's way or create any kind of damage to anything downstream as we remove the debris. So we'll start out, you know, large and work down. If we have large debris like logs, branches, wood, beaver dams, often we'll use an excavator with a thumb on it, other large equipment, cables, mandrel. I've seen excavator with a thumb and use like a piece of utility pole to try and push stuff through, manned entry, chainsaws, etc. And if the culvert's large enough, sometimes you can get a small excavator or skid steer in it. If you've got silt, depending on the size and your conditions, you can use a vac truck, which are pretty handy. You can use a sewer jet. We had one when I was at the county from the sewer district for smaller pipes. It was pretty handy. You can blow it out with a fire hose. The photo we saw earlier had a bucket line being pulled through, and skid steer if you've got the room and if it's dry and you don't have a permit issue with getting into the waterway. So one of the other issues we have is scour repair, and how you do it depends on the severity of the repair, but you want to consult a hydraulics engineer to make sure you're using the appropriate materials. You can use stone, grout, concrete, grout bags, which are large geotextile fabric bags that get filled with grout. If you're working in the stream, you may need environmental permits, or consult with DEC and your local soil and water conservation folks to get the right permits in place. And here's a video from Michigan DOT. They had a bottomless concrete culvert that they had scour issue with, and they want to put some riprap in. And the folks at the Michigan DOT maintenance shop built themselves in their monster garage a raft, if you will, to float in riprap.
Willie,
Yes.
we have a comment here that says maybe mention the culvert cleaner from Washington County.
Okay.
And we also have a question. Does the NYSDEC restrict removal of beaver dams at culvert inlets?
DEC does restrict removal of beaver dams. In New York, you will typically be required to get a beaver permit to remove the beaver dam and the beaver house. So in this photo, they're floating the box, the raft, right into where they want to drop the stone. And there it is, right where they wanted it. At the inlet or outlet, you may want to put a stone apron. This is a detail from Georgia DOT, and this is what they use down there. You'll want to have that riprap sized appropriately so it's not going to wash away. Another option, in addition to culvert end sections, which are standard fitted to the culvert type you're using, is you can do a concrete apron, and that can also minimize potential scour at the inlet and outlet.
Willie, we have one more question.
Okay, sure.
It said this gentleman was watching a video of a full-sized cougar mountain lion that had taken up residence in a corrugated pipe. He said that this is rare, but how often do large and small animals come up?
With animals taking up residence, I don't know how often it is. My experience has been with beavers in clogging culverts with running water. And then the ongoing issue we've had is with under drain outlets, where those daylight, and you tend to get rodents moving in there, clogging up the under drain. So that's why you often want to make sure those outlets have rodent guards. The mountain lion, I think that's something you start to bring in the DEC wildlife biology folks in, that, you know, well above my public works pay grade. Okay, so culvert repairs. How do you fix this stuff? Well, if you have undermining repairs or undermining, you want to fix the undermining with grout, and then you may want to do toe walls or cutoff walls. Invert repairs, you can look at a concrete paved invert, armor plate, or cementitious composite mat. Joint repairs, you can look at a couple of options, either grout or internal bands. Footing repair, it's standard concrete repair, and then you can also look at relining options. So toe walls or cutoff walls, they may prevent, if they're deep enough, undermining of the culvert in scour prone areas. You're still going to get the scour hole, but it'll keep it from progressing under the culvert and destabilizing it. But you need to check with your hydraulics folks and make sure it's beyond the depth of maximum expected scour. So basically with the cutoff wall, it's anchored to the end of the culvert, and it is down deeper than the expected maximum scour depth. Paved inverts. Basically, you're putting a new concrete invert in the bottom of the existing culvert. In this case, you can also do armor plates and geosynthetic cementitious composite mat. Now for the paved invert, you need to divert the stream. You form and place the concrete, make sure it cures, and then restore flow. And this has the advantage of more smooth laminar flow, so it may help your capacity a little bit.
Willie, we have one more question.
Sure.
What are the best installation practices for installing a larger than required culvert for future lining?
What you would want to do with a larger than necessary culvert is determine your capacity, upsize it to the point where you can make sure that whatever you're going to be putting in the future would be adequately sized. And then let it go and monitor it. And then years from now, when it's time to reline, you slide a new one through. Which is easier said than done. Another option for invert repair is armor plates, and California Caltrans has used these, and basically it's a steel plate in the bottom. It spreads out the flow, it resists abrasion. It's fairly thick plate, and here's a photo of it installed and the installation going on. Now, this may not play well with DEC because it doesn't give you a concentrated flow in low flow conditions, so it may not be the best option in all cases. This is a geosynthetic cementitious mat. Basically, it's a couple of pieces of geotextile with a mortar mix in between them. It's like a quilt, and it comes in a roll, and this says do it in pieces and shingle it. Virginia DOT has used that, and what they do is they just roll it out from the downstream end to the upstream end, and you divert the water. Once you get it installed in place, wet it up, let the concrete cure, and then restore stream flow. Now, if you have any distresses or undermining or anything in the invert, you'll need to fix that first before you put the mat in. Joint repairs. Options: you can do internal bands, chemical grout, or concrete collars. Internal bands, this was from a slip line project in Saratoga County, and these are the internal bands that held the spiral rib slip liner sections together. But if the joints are separated but not displaced, you can use something like that. They would be soil tight. They're not necessarily watertight, and they're put over the joint and held in place with threaded rods. You just want to be careful doing this, because with the threaded rod, you can see the bolts are threaded rods here. If those could potentially catch debris. Flexible chemical grout injection, it's injected through the joints or sometimes injected from the surface down into the joints, and it creates a collar around the leaking joint. And I have seen this used, and it will close the joint and keep material from coming through. And here's a Florida DOT detail with a concrete collar. This one, unlike the others, which you can do in place that don't really require excavation, this one does. So you have to excavate around the joint area, make sure the inside is sealed up, and then fill it with concrete. Because if you don't seal up the open joint, you're going to fill your culvert with concrete when you do it. Okay, relining. So we'll talk about some of the relining options. There's slip lining, shotcrete and spin cast, and cured in place pipe. So slip lining, you can use a variety of materials. You can use corrugated metal pipe. You can use smooth interior metal pipe. You can use a a plate pipe arch, or you can use polyethylene. And here's some photos of smooth interior, solid steel pipe going into a corrugated. And here's a relining job that we did when I was at Washington County. This was a bottomless arch and bottomless corrugated arch, and we relined it with a new, slightly smaller corrugated arch. Assembled it in place, slid it in, and then as you can see, there's about a 6-inch gap between the old one and the new one. We then needed to form this, and the forming was a little bit challenging because of the skew and the corrugations. So that annular space got filled with grout, and in this case, we had the ability to excavate from the top, cut through the crown of the old arch, and use self-leveling grout there. With the spiral rib slip line, that has grout ports, and once that was in place, grout was injected at the ports throughout the pipe and in both cases, you end up with a steel and concrete sandwich with steel on the outside, concrete in the middle. So you've got a good structural pipe. This is a polyethylene pipe. Same thing. That got slip line through, and then the pipes here you see were the grout injection. This was a smaller diameter pipe. Okay, other option. The thing with slip lining is you got to be very careful. You can't have a lot of deformations, otherwise it's not going to slide through. If you have some more deformations, you can use something like spin casting or shotcrete. Concrete puts a new concrete interior in it, uniform thickness. This machine basically sprays concrete as it's being pulled through the pipe. It's a lot more forgiving of distortions. But again, if you have any voids or anything, any distresses in the invert, you need to take care of those before you spin cast. And for larger pipes, you can shotcrete, probably much larger than in the photo, because that's a mighty tight space to be doing shotcrete. And then relining cured in place pipe, which is basically a felt liner that's impregnated with an epoxy resin. And it's installed using water or air pressure, and then either hot water, steam, or hot air cures that in place. But you will take it out of service during installation, but you'll have a new, basically plastic pipe inside. This is a waterborne illustration here in the photo where you've got the resin impregnated tube and it's inside out, and as it's put in place, it's filled with water and the water just pushes it into place, and the hydrostatic pressure keeps it against the old pipe. The water is then heated, so it's cured, and then you have a new pipe in place. That's what the back end looks like as the inversion process is being completed. And I've been involved with with at least one project using this several years ago, and it's pretty slick, but it's going to be used in a place where it's not economically feasible to dig and replace a culvert. So if you have bottomless pipes, like the arch I saw earlier, we had to do footing repairs. It's similar to any other footing repair, any other concrete repairs you would do. The challenge is tight locations. You're going to be doing a lot of handwork, and you're probably going to need to do stream diversions, and getting to the end of this sound concrete and getting down below scour depth are things you're really going to want to take a look at. So basic process for this is you're going to do a bypass. You can see the bypass culverts here. You can see our damaged concrete that's going to get fixed. You're going to cofferdam that, get the unsound concrete out, clean and form. Use a bonding agent if you need to. Place and cure your concrete, and then reestablish the stream. So we've talked about some common deficiencies in culverts. We've described PM in culverts, and we've gone through some repair procedures. So now it's time for our review questions. So corrosion in metal pipes can lead to which of the following deficiencies? Invert damage, deformation of the pipe, undermining, or all of the above?
Can you see the result?
I can't, I'm not seeing the results.
Right, so we have 5 for invert damage, 2 for deformation of a pipe, 0 for undermining, and 106 for all of the above.
Okay, and all of the above is what we were looking for. Great. Okay. Question 2. What would be a PM for scour? Placement of a riprap or concrete apron, installation of a tow or cutoff wall, slip lining, or installation of geosynthetic composite mat or armor plate. A and B only, or all of the above?
I'll give you guys a few more seconds, then I'll stop the poll. Looks like we have 4 for the first one,
Okay,
0 for installation of tow, cutoff wall, or recommend. 1 for slip lining, 1 for,
okay,
and the most is 78 with 4 A and B.
okay, and A and B is what we were looking for, because slip lining or cured in place may accelerate the velocities and could potentially make it worse, and geosynthetic and armor plate may or may not have an impact. Okay. And our final question. Which is not a viable method for lining a culvert with, I'm going to say, deformations? Cured in place pipe, shotcrete or spin cast, slip lining, or none of the above? And well, we did have, well, we were talking about this. I had a couple of questions. Spin cast or comments, spin cast is not considered a structural rehab by New York State DOT. DOT may not consider it a structural rehab. However, if you're getting it adequately designed or engineered, it could be, depending on the thickness of the concrete and any reinforcing. Other DOT recommends shotcrete for inverts that can accommodate low flow channels. Shotcrete can work rather than poured in place. And then if we have a culvert outflow that exits to a DEC wetland tidal river that flows to Long Island Sound, do we need a DEC permit to use excavator to clear outlet of debris? maybe. If you're putting the, if you're putting equipment in the creek, absolutely, but you probably will need it at a minimum a consultation. And
I have the results for the PDH question. We have slip lining coming in at 59.
okay, and slip lining is what we're looking for. If you have deformation, slip lining is probably not going to work for you. Okay. That concludes our discussion today. So thank you all for participating, for, listening to me for an hour. Hope you learned something or got something out of it.
Thank you guys for tuning in for our topical Tuesday or foundational webinars. Thank you, Willie, for presenting, and we'll see you guys next week. Well,
Okay.
see.
Great.
Bye, everyone. Have a good rest of your Tuesday.